Leetcode 55 jump game. It's a medium problem, but I would say it's something between easy and medium because it's an entry-level problem to a class of problems related to greedy strategy. Yeah, so greedy algorithms, greedy strategy is something very common throughout Leetcode and related algorithmic problems during interviews and so on. And it's definitely something that you should study and know very well. Yeah, and of course there are also like common algorithms that depend on that strategy or on that way of thinking, like Dijkstra, and there's also very common knapsack problem, fractional knapsack, which relies on for which we can solve using greedy algorithm. Yeah, so or greedy strategy, yeah, because it's not one algorithm, but it's like a whole class of approaches in which we can solve certain types of problems. Yeah, so definitely that's an entry level for that kind of strategies and should be studied well and understood well. And here is the description. You are given an integer array nums, like the most standard of standard Leetcode introductions or starting points. Usually you have an array of something, and this case we have integers, and this array is called nums, like almost all Leetcode arrays are called in that way. Yeah, so you basically have a list or array, like a linear structure with integers inside, and the integers are in this case only positive. Yeah, it could be 0 and positive. There are no negatives for sure. Yeah, if you scroll down, usually you have it listed under constraints, some additional information to your input, and in this case those are only either 0 or positive. Yeah, and reading further, you are initially positioned at the first index, and of course it has some kind of interpretation. What do they mean? How should we understand this input array? Yeah, it represents how far can you jump. Yeah, and initially you are positioned at the first index, meaning at the 0th index, and each element in the array represents your maximum jump length at that position. Yeah, so already you can start thinking about the greedy approach. You should either update some kind of variable, if only like in a greedy way, only if it exceeds, like if the new jump exceeds the thing that you have already already accumulated. Yeah, otherwise leave it the way it is. Yeah, so that's the greedy approach, or like small preview to the greedy approach. And return true if you can reach the last index, or false otherwise. Yeah, and as we have mentioned already, we can have zeros. So if we have many zeros, one next to each other, then we won't be able to reach the last index. Otherwise, we probably would, because we can have also very long jumps. Yeah, we can have jumps that are equal to 2, 3, 4, but maybe 100 is also possible. Actually, we can have 10 to the power of 5. Yeah, so theoretically there could be such a huge jump already at the very beginning that is already tells us that we can jump well to the end. Yeah, which is something that we should also think about and put in our solution, so we exit early on success and we also exit early on failure. Yeah, if there are too many zeros, then we know that for sure we cannot reach the end. And let's take a look at the examples, and then we will think about them in greater depth. Using XCaliDraw, I will draw some additional explanations, maybe write down some notes, and so on and so forth. But first of all, let's take a look at what was written here. So we have following input array: 2, 3, 1, 1, and 4. Yeah, in total 5 numbers, and those are all positive. So for sure you can say that we can jump to the next, and we can jump, for example, one way is to jump from the first step using 2 jumps from index 0 to 1, yeah, then 3 steps to the last index, and so on. Yeah. We can jump from the first step using 1 jump. So this jump is like the maximum amount of jumps you can do, and you can do like from here to here, and then from here to here. But of course, you could also jump from one to the next and so on. Yeah, because here we only return in Boolean. We don't have to have like the least amount of jumps. Yeah, that's also another problem, but it's a bit more complicated. Here we just return in Boolean if we can ever reach or not. And of course we can't only if there are too many zeros. That's it. And the next example is such an example that we can jump from first element, 3 jumps, we can reach, for example, 0, but from here we can't reach anything. Yeah, and from 2 we can also jump till the 0, and from here we can't reach any other place, and 1 can reach 0, and so on. Yeah, so you will always arrive at index 3 no matter what. Its maximum jump length is 0, which makes it impossible to reach the last index. So if there are enough zeros somewhere in between, that means that we cannot reach the end, and then we have to return false. So let's copy both of those examples, this and this. First is okay, and second is not okay, and we have our jump game. Yeah. True or false, Boolean answer. That's one thing that we have mentioned, and the second is greedy approach. Update only if it makes sense or if it gets better. But basically, that's the greedy approach. And the algorithm that we might use is, in each step, we have following options. There are only a couple options that we can do. Terminate with failure if what happens? If current I is, or current index is greater than what we have accumulated so far. Let's make it of this. Yeah, we have to store, we have to accumulate somewhere. So we need also some additional variable for that. We can write it down, by the way. Let's store the best, or let's store the accumulated jumps in variable furthest. And each iteration, in each step, we can already say that either we can't go anywhere because we have already reached such an I that the furthest we have accumulated so far is less than that I or that index, or we update greedily. How do you write it correctly? Like this. Meaning you take max between previous value of furthest and I plus step, the value at current step. Or the next thing is terminate or exit early with success. Yeah, because furthest is so big that it exceeds n or n minus 1. Yeah, because we start from index 0. And that's it. Those are all the options. So how will it proceed for this example? Now let's create this furthest. We can do it using a table. So we need just, I think, 3 variables. I, step, and furthest. This is I, this is step, and this is furthest. Yeah, and let's start here. Let's create a table like this. As of course, the first I will be 0. Step is equal to 2. Yeah, and the furthest is maximum between the previous version and I plus step, yeah, which is 2 in our case, since we start furthest with 0. And the next I is 1. Step is 3. Yeah. Furthest we can go is 3 plus 1, 5. Yeah, and already at this point, we know that, by the way, let's move it down. Let's make it smaller since we already terminated, and we can say that n is equal to 5. Yeah. So already at this point, furthest is exceeds n minus 1. And we can be sure that we can reach the end. And here is the same, actually. N is also equal to 5. But let's move it below here, and let's do the same table. Yeah. So let's see how it will go here. We start here, and first I 0, of course. Step is 3, and furthest is also 3. Yeah. Then next index is 1. We move here. Next step is 2. And next furthest is 2 plus 1 is equal to 3. And 3 is not greater than 3, so we just leave it the way it is. We move to the next one. That is 1. And the furthest we can go is still 3. Then we, 2, the index is 2. The step is 1. And the next one, the index is 3. The step is 0. Yeah. And the furthest we can go is still 3. Yeah, because we haven't reached further step, but the I is already, we have already reached like 4th place, yeah, starting from 0. And the furthest we can go is 3, meaning that we can't go any further. Yeah, we have to terminate. We have satisfied that condition, meaning that we have reached such an index which is greater than the value accumulated so far, or maybe not the index itself, but the index plus 1 is greater or equal. Yeah, that would be better since we start from 0. that would be more precise. Okay, so that's it. Now we have to convert it to Python. Furthest is 0. And length of nums. And for I step in enumerate nums, we do the following. First, this condition. If, not step. If I plus 1 is greater or equal to furthest, then return false. Furthest equals max between furthest and I plus step. Yeah. And if furthest is greater or equal to n minus 1, then return true. Otherwise, continue. And if we reach the end, then we also have to check this condition, and that's it. Let's see. Wrong answer. We have false. Let's see. Looks like we made this too strict. I plus 1. So let's correct it. And the first thought was better. Probably. Let's see if that's it. Because I think that, because at the beginning furthest is 0, so I plus 1 would always cause us to terminate at this very step. Yeah, so that's more correct approach, or definitely correct approach. And let's see. We beat 67%, and let's see if we do this trick. If furthest is less than I plus step, then this, let's see if it gets faster. And now we beat 82%.